So in this practical, I will introduce a software that can be directly used in your research or actual practical application. So that's the MTG2. Then the material can be downloaded from this website. There are I can show in the website. So when you go to the website, then there is some explanation for the software, some papers, and there is a Linux binary file, Windows binary file, and there are some Mac binary file in the older version, but and there are manual as well, so you can download from the website all of this material, including example 1 and 0 and 1 that will be used in this practical. But there are other examples as well. Probably you can have a look at the manual. Then there are a number of different options and practical applications. Okay. So algorithm for grammar. So there is command, the MT2, and it need some fem file. If you are familiar with Blink file, then it's much easier to use. Otherwise, please have a look at the manual how to use. So you need fem file and some data file and genomic relationship metrics that can be constructed from MT2 software itself or Blink or GCTA. And it can also fit some covariate as well. There's CC and there's QC. And you can specify alpha file, and also it can be specified for the starting value, and number of different traits can be fitted. So you can try for the example 0. So you can download example 0, then put in the directory, same as in the binary file in Linux or Windows, or probably in Mac you can use version 2.05 for this example. Okay, so we can try as it specifies. So give mt2, then give a fem file name, so fem data file fem, and general relationship metrics file. Okay, then this mode is a number of traits. So when you specify 1, then single trait analysis. So you can try like this. Yeah, then you get this value. So compared to the R code in the last practical, they show it as a log likelihood -478, and also from the MTG2 you get the same, and also residual estimate residual variance and estimate genetic variance. You get the same as R code, but MTG2 is much faster compared to R code. Right? So when you see the alpha file, then you can see estimate residual variance is 0.82, estimate genetic variance 0.19, and heritability is 0.19. Okay, this is right ratio, and this is information matrix that's from second derivatives. That is also one of the alpha file. Okay. Yeah, so you can compare the result with that from the AIRammer.r that used in the last practical. Okay. So here is a simple instruction how to prepare input file. Also, you can refer the manual. There are greater details in how to prepare inputs and what output look like, something like this. Briefly here, The Plink PEM file is your PEM file that used in estimating the GRM, and genomic relation matrix for -g command. That format is something like this. Also, you can use GZ format as well as bin binary format as well. So it's quite flexible to use. And in order to construct genomic relationship matrix, you can use Plink or GCTA. Also, MTG2 can also estimate genomic relationship matrix. So have a look this one, how to prepare genomic relationship matrix. So I can show somewhere where is. So when you download the manual from the website for the MTG2, then there are a number of options that one of them is include how to estimate GRM. I can show briefly. Then, yeah, so then there are some models and extra options, and yeah, here estimating relationship metrics 39. Yeah, so chapter 6, then this is show how to estimate relationship metrics as well as weighted genomic relationship metrics. Yeah, so there are a number of things. So you can have a look. Also, there is option that how to estimate numerator relationship metrics based on pedigree. That can be possible too using MTG2. You can use binary format by using testbg, right? So I don't know whether we have binary format. Yeah, there is a binary format. Then you can do exactly the same, but now instead of dash g, you can give a base dash bg, then give the name of the binary format grm.bin, then you'll get the same result, right? So this difference is because actually genomic relationship matrix is different. That's a slightly different method. So more specifically, the previous one is scaled by actual variance of a SNP coefficient, but this one is based on expected SNP coefficient as 2pq. Yeah, but basically they, whether using binary format or text format, they're supposed to give the same values. But this is just to show how to use binary format the file that is possible with MTG2 SPG, or the GZ file as well. That format can be fitted using testZG. So this detail is all in the manual. Okay, so then phenotypic data file format looks like this. So the first one is family ID, second is individual ID, and this is the first trait, second trait, third trait, and so on. Okay, so then if there is missing values, then it should be coded as NA. And this is how to fit covariate, also shown in the manual. And so principal components are widely used in genetic analysis. Then you can also get the principal components by this command. Then yeah, then it will. So maybe we can try MTG2. Then you get the. Then give the genomic relationship matrix is called in toy.rtmx here. Then if you want to the first principal component, you can give 10. Okay, then let's have a look. Where is Yeah, then try. Yeah, if there is no error, then this shows there is no error. 0 means. Then where is output is the same as the general relationship matrix file name. Then dot eval is eigenvalues, and dot effect is eigenvectors, right? Let's have a look. How does it look like? This is ordered in the eigenvalues, and this is eigenvectors. That is n by 10 matrix. Also, you can do full eigenvector matrix specifying here instead of 10. You can give the full number of individuals, then you can get the full eigenvectors. Okay. Yeah, there are also extra options. Then you can have a look what option of there. There are inverting options or bending options and number of different options. Okay. Okay, so let's try multivariate linear mixed model with 5-trace model. So if then I like to go to the server that has the example 1 directory. Also, you can download in your machine and you can work on the machine. But I already have the file and folder in this server, so I like to go here. Okay. Then also I like to go the same. Okay. So you can follow the command give mtg2. So although this example give dot two mtg2 dot 0, that is a old version, but the recent version has all mtg2, just mtg2 that is updated. So you can use mtg2 rather than mtg.0. Okay, then we can try to test v, specify fem file, specify data file, specify general relationship matrix file, then give the number of traits. Okay, now we can try. Also, dash COVE1 is parameterizing residual covariance in case that one individual have a repeated measure across different traits. So in that case, you need to model residual covariance. That is also possible in the MCU2. Yeah, there are output files. So this is now calculating because the number of parameters is large, so it takes some time. Then I'll show in the same data set then how to make it faster. So to speed up, you can use eigen decomposition technique. So when you go to the here, then you can use previous dash PCA, then you can get the eigenvalues and eigenvectors, that is full eigenvectors n by n. Once you get this one, then you can use this EIG rather than this G. So this EIG means I will use eigenvalues and eigenvectors, right? So can try MTG2. Specifying fem file, specifying data file. Now we specify eigenvalues, eigenvectors, but you can only give the prefix for the genome relationship matrix name. Okay, then same as before, we give a number of traits, and we give an alpha file as just give an arbitrary name, any name, but this for the item decomposition technique. Okay, so this is running, and you can see the roughly time took for inverse here around 21 seconds, and derivative is for around 1.3 seconds. And how about when you use identity composition, how long it takes? It's finished. So V matrix is 0.003 seconds, and derivative is 0.007 seconds. So compared to here, it actually speed up more than 1,000 times, right? A lot more than 1,000 times. Then let's see whether the result is exactly the same or not, because this hasn't finished yet, but we can still comparing the first iterations and second iteration and so on, whether that progress is the same or not. So we go back to the first iteration. Yeah, that's exactly the same, right? Port 9, port 3, port 9, port 3. Then second iteration, 4855572. Get the same. Then this doesn't come up yet for the third iteration, but let's see for a moment, then we can see whether they are same or not. So yeah, now 4782 339. Yeah, so the third iteration is exactly the same. So I think the rest of them is exactly the same. It will get actually give exactly the same result, but the speed is when you're using identity composition technique is more than 1,000 times faster compared to traditional approach. Okay, so this shows it can speed up a lot faster for your research. Uh, yeah, then the next question is, can you also estimate breeding values? So how to estimate breeding value or genetic profiling score in human genetic context? Then there is an option or command -bv, so you can estimate uh, genetic profiling score. The breeding value term is come from the animal genetics, because this linear mixed model is widely used in animal genetics. But now, as I show in the first lecture, so linear mixed model is now emerging tool in human genetics and medicine, so it can be used in the field, also across multidisciplinary field as well. Okay. Now also there are a number of different models, including random regression models. So this is tackling genotype by environmental interaction. So there are also some instruction how to use this model. So if your research focus on some kind of G by E interaction or some related interaction study, then this model can be useful in your research. Okay, so I'm not going to go much detail, but if you are interested, you can have a look the manual. There are some examples and how to use, and all the details are there. So I recommend that probably download the manual from the web and have a look the the manual and following the some example file as well. Okay, thank you very much for listening my lecture and practical. Hopefully, this can help your research as well as some practical application. Thank you.